trig ratios, we look at SOHCAHTOA, and here we have opposite and hypotenuse, so we know that it is sine. And we have the degree of 63, so we write sine of 63 equals opposite over hypotenuse. This one's going to be a little bit more tricky to solve because the missing variable is on the bottom. So now we are going to cross multiply. So 12 is equal to x times sine of 63. And to find x, we're going to have to divide both of the sides by sine 63. And then we can cross out the two sine 63s because one's on the numerator, one's on the denominator on the right side. And then we can plug it in to our calculator, 12 divided by sine 63, which gives us our final value. For the next missing length, we are trying to find our opposite length because of the given angle that we have. So opposite and adjacent, because we have that length, will be tan, because TOA is opposite and adjacent. Tan 21 equals opposite over adjacent, and we only have our adjacent length, so we're going to write x over 9.5. Plugging that into our calculator, we can see that x is 3.64 centimeters. So for this, we're finding the angle of B. We have our hypotenuse, and then across from theta, we have the opposite because that's the angle we're looking for. And if we think about which function deals with hypotenuse and opposite, we know that that is sine, and we have theta because we don't know the angle. And then we can write opposite over hypotenuse, which we have given to us. So therefore, we can just write the 12 over 21. And using the inverse function on the calculator, we can isolate theta. So theta equals sine inverse over our ratio of 12 over 21. And that gives us 34.8, which we can then round up to 35. And it's not asking for this in this question, but if we wanted to find angle E, we can add 90 and 35 and then subtract that from 180 to get our angle E. For this next example, we're looking for angle B and angle C, and labeling out the triangle with the hypotenuse and the adjacent, we have those two, so we can use cosine. So we can say that cos theta equals adjacent over hypotenuse, and because we have both of those numbers, we can fill it in, so 4 over 9 is the ratio. And then if we isolate theta and we do the inverse of cos, 4 over 9, we get theta is 63 degrees. And now that we found the degrees of theta, we can add up 90 and 63, subtracted by 180, and get angle B. So here for secondary trig ratios, I am just writing out the hypotenuse, the opposite angle, and the adjacent. And we can use cos to find angle C because we have adjacent and hypotenuse, and we can just fill that in as the ratio 12 over 40. And from there we can do theta equals the inverse of cos to the ratio 12 over 40, and then plugging that in on the calculator, we get 72.5. And now to find angle B, we can add 73 degrees and 90 degrees, and then subtract that from 180 to get 17 degrees for angle B. Now over here to deal with our secondary trig functions, I am just writing out the reciprocals. So cotangent is tan, secant is cos, and cosecant is sine. And they're the reciprocals, they just flip. So starting out with cotangent of angle C, we know that that is just tan but flipped, so the reciprocal. So I am just writing out A over O, so adjacent over opposite, to remind me, because tan is opposite over adjacent, so I'm just flipping it. And then to fill that in, I'm writing 12 over 11 as the ratio. We're leaving it in the ratio form, so now moving on to secant of angle C. I'm just writing out that it is hypotenuse over adjacent, and we see those numbers in our triangle there, so the ratio is 40 over 12. Now to move on to cosecant of angle C. I know that it equals the hypotenuse over opposite, and then I'm looking at my triangle and I'm filling that out. It's 40 over 11 as the ratio. Now determine the value of theta to the nearest degree. So first we have cosecant theta equals 9.45. And to do this, we're typing sine inverse, 1 divided by 9.45 in our calculator, which gives us 6 degrees. And then for cotangent, we are doing tan inverse, 1 divided by 1.1578. So for this one, I just wanted to show how I'm getting the formula to put in the calculator. But basically, cotangent is just 1 divided by tan theta, and then of course equals to our degree number. And then if we do the calculations to isolate theta, we end up with tan inverse, and then in brackets 1 over 1.1578, which equals theta. So in our calculator, that's how I'm putting it in. And so here I'm just showing that it's the same process, just on my calculator. And for secant theta equals 4.99 degrees. I'm just typing in the cos inverse and then 1 divided by 4.99, which gives us the degree. So for the first set of these questions, we're going to look at the 30, 60, 90 special triangle. So for tan of 60, we are looking at opposite over adjacent. So we're going to write the square root of 3 over 1, which is the ratio. We can simplify that just to the square root of 3, which is a key point. So next we know that secant is the reciprocal of cos, so it's hypotenuse over adjacent, which we can write as a 2 over 1 ratio. Finally, for cos 30 degrees, it is the square root of 3 over 2, because we are looking at our adjacent and our hypotenuse. And for a 45, 45, 90 triangle, if we're looking at sine 90 degrees, we see the ratio of 1 over the square root of 2. We can finish this by rationalizing the denominator, so square root over 2 over 2. With this next triangle, you can really see the correlation from a 30, 60, 90 triangle, as it's all multiplied by 12. So if we relate it back to our original one, we can just see that it's multiplied by 12. And we can write it and then simplify it as you see here. On to sine law, I'm just writing little a, little b, and little c right across from their big letter angles. So at the top, it says we're finding angle A. So because we're finding angle A, I'm just going to write sine A over little a is equal to sine C over little c. And I'm just subbing in the corresponding numbers that I have labeled out on the triangle. So I'm just using the formula and solving it. And because h is greater than a, there's actually no solution to this problem, but that's totally okay, that's fine. So we're finding length of AC, and that is opposite from big B, so we know that's little b that we're looking for, so we can just do this formula here that I have written out, and then sub in the numbers, and I'm just solving it here as I would with any equation, and then we can cross out, and finally we get our answer. Looking at this word problem, I'm going to put my 2 posts there, and then the part where he kicks from is going to be the third dot. And I'm just connecting the lines and then labeling it. A, B, and C, and then little a across from big A, and then same with the rest of the letters. And we are trying to find angle C, so I'm just writing out the formula. C squared equals A squared plus B squared minus 2AB cos C. Now that I've done the calculations and filled it in, I'm just solving it like a normal equation. I'm bringing over the A value and subtracting that from the C value. Because we're multiplying negative 23.65 into cos C, we're going to bring it over, so we're going to divide it out, and then they end up canceling out on the right side. And I'm just putting it into my calculator now that we've condensed it. We're able to find out the angle by using our cosine law. Because it's a word problem, I'm just finishing off with my therefore statement. So for this question, first we're going to be looking for our acute angle, so we're going to have to do the inverse of tan. As the degree we're doing in this example is negative, we know it needs to be in a quadrant that tan is negative, so quadrant 1 and 3. So our related acute angle is 66.5, and now I'm taking 180 minus 66.5 because that's the angle that it's closest to, and I end up with 246, which we know is our principal angle, which is also known as beta, and our related acute angle is 66.5. So this next question is a negative angle, and so first we're just finding the acute angle, and in our graph we are actually going to be looking at the bottom two quadrants where we know that sine will be negative. So the angle that we got from our first calculation, we're going to plug in. We're going to do 180 plus 17.5 and then 360 minus 17.5 because we're looking at the bottom two quadrants. And so a nice way to check your work is instead of sine x, we can plug in one of the angles that we found and it will give us our original equation. So for trig identities, we are looking at left side equals the right side, and we're going to solve it. First, we're actually going to start off on the left side. Look at the top, cotangent theta is also equal to cos theta over sine theta as its quotient identity. The reciprocal of secant theta is 1 divided by cos theta. And then we just have sine squared theta at the end. And by grouping, we can cancel out. So we can cross out a cos squared theta, and then just cos theta we can cross out. So that leaves us with 1 cos theta. And we can cross out both sine squared theta. And then we are left with cos theta, and then multiplied by 1, so just cos theta. So moving on to the right side, we can look at this and see that we're going to need to factor out. So we can actually bring out a cos theta, and then on the inside of the brackets, we still have a cos squared theta, and then plus a sine squared theta. Sine squared theta and cos squared theta always equals 1, and we know that from our Pythagorean identities. And we can simplify it to cos theta multiplied by 1, which is just equals cos theta, and left side equals the right side. And then I did the little square at the bottom to show that that is all my work shown.